Okay, so last time in the last video, we overloaded the greater than operator for the vehicle class. So here's the function definition. We use this keyword operator. We return a Boolean. We take as an argument the other vehicle, the vehicle on the right, in this case, a motorcycle, which has cost of 3,000 and a mile range of 200. So we have this if statement, and if the vehicle on the left's cost is greater than the vehicle on the right's cost, and the mile range of the vehicle on the left is greater than the mile range of the vehicle on the right, we return true. Else, return false. So we ran this and we saw that the camper van was greater than the motorcycle. And I pointed out that operator overloading is not supported in Java, and it can be a good idea to overload certain operators. One of my assignments is operator overloading for a matrix class. Now, this is an example in which it's generally considered a very reasonable thing to overload the addition, subtraction, and multiplication operators for a class like a matrix class, because a matrix is a mathematical object and these operations have particular definitions. For a vehicle class, it's not such a, perhaps not as good of an idea. It's not as natural of an idea to overload certain operators, like adding two vehicles together, which we did last time as well. But it's a feature in C++. It's a tool that's available if you would like to use it. It's just, let me not get into too much of the theoretical details, the benefits, pros and cons of operator overloading. It did occur to me to point one thing out, to mention, if there's a preference not to use operator overloading on the part of in the mind of the programmer, there is an alternative. So I think of this as like the Java style of comparing vehicle objects as one example, vehicle objects or whatever class you like, people objects, person objects. We could write a function called something like bool has greater vehicle attributes. And we could take as an argument the another vehicle, like a vehicle on the right side of the, not the equation in this case, or the inequality, but it's going to be a function argument. Let me just copy this code real quick. The function definition is actually going to be the same in this case. So, except the syntax is different. The syntax of, we're not operator overloading in this, overloading an operator in this case, has greater vehicle attributes. That could be a function that we would like to be a member function of this vehicle class as well. Probably wouldn't include both of these things because there's obviously repetition here. So this works the same way. So we say camper van dot has greater vehicle attributes compared to motorcycle. And assuming I haven't made any mistakes, we should see the same Boolean being displayed twice here. True or false, whichever it was. Yeah, true and true. So this is something you can do as well. Maybe you want to make this function name a little shorter, but at this point, it may be apparent why we might prefer to overload an operator rather than having a function name like this. Maybe you don't care to compare the mile range, you just want to compare the cost. In this case, you might rename this function as greater cost, and you just delete the the second bit of the comparison here. If you say so, you say if this cost is greater than the other vehicle's cost. And again, you don't have to say this here. I think it makes the inequality look more symmetric and more mathematically appealing. But it's anyways, that's a kind of a personal idiosyncrasy due to my background in science and math stuff. Okay, so yeah, you could do this as well, and it would work. Just wanted to point that out. Operator overloading is not something that must be implemented in order to compare attributes of classes. That's probably obvious. Okay. And this function name is unambiguous, has greater vehicle attributes, whereas the comparison operator greater than is perhaps somewhat ambiguous. Okay. But let's overload a couple more operators, and I make an observation at this point in my slides. So far, we've been comparing objects of the same type. So this is a vehicle, it's a pointer to a vehicle object, but loosely speaking, it's a vehicle object. Other is also obviously a vehicle object. So our operands, or excuse me, our operators that we've overloaded so far, the equal, the equality operator, the addition operator, the greater than operator, they've all been binary operands, binary operators. That is, they take two operands, and they've all been of the same type. That is, the operands have both been of the same type. They both been vehicle objects. To show this in code, camper van is a vehicle object, motorcycle is a vehicle object, and I guess I commented out the if statement where I compare objects for equality, but camper van equal motorcycle, this would be returning a Boolean, and this is a vehicle object, as we can see if we hover. In particular, camper van is a variable of type vehicle. Motorcycle is also a variable of type vehicle, obviously. And same thing for the greater than and plus operations here. So what about overloading a unary operator? And what about using a binary operator that takes two different types? So we've actually seen hundreds, maybe thousands at this point of examples of this first case, a binary operator that takes two different types. And what am I talking about? This is one example. So cout is an object of the output stream class, the OStream class in C++, which is a very complicated class that I've poked into a little bit by opening up the external dependencies. Go here and go to the standard namespace. You can dig into this class. The inheritance hierarchy is complicated. Okay, so let's just not get into that. So this is an object of one type. This is a character array. We could also print the number 1, of course. We could print camper van dot something dot mile range if it's a public member variable. But we could do arithmetic here, of course. But my point here is that this is an object of one class. This is not an object in this case. It could be an object of the string class. So let me do that example. String a equal something. And now if we say cout a, we have an operand of one type on the left side of this operator, which is called the insertion operator, or the put out operator, if we like to be more colloquial. And this is an object of the string class. You see, of course, it is. So it is a pretty convenient and desirable thing to do being able to make this work. And we have different types here, so that's an interesting thing to observe. So overloading the stream insertion operator is a very common operation, and I usually just defer to Microsoft's website here. They give an example of a date class, and so a date consists of a month, day, and year. And the typical syntax that's used is, I'm not going to try to explain it. Again, cout is a black, it's more or less a black box, and the stream insertion operator can get very, very complicated. So I'm just going to copy this example from MSVC's website, Microsoft Visual C's website. Their documentation is pretty good. And what is this? Oh, it's a has greater business that I commented out. Oops, excuse me. So friend output stream, returning an output stream object by reference, which is an interesting thing. The operator, we are overloading an operator. Sometimes people omit that space there. There are certain reasons for that. We take, now this is a new point. We take an output stream object by reference, we pass it. And we also pass in this case, not a date object, but a vehicle object. And maybe we call this V object, vehicle object. So we declare this as a friend function so that we can have access to these private member variables here, cost and mile range. I might poke into removing the pass by reference, removing the pass by reference and removing the return by reference, and we might investigate what that results in a little bit of detail. So we talked about friend functions previously. Friend is invalid outside of a class definition. That's that red squiggle there. Okay, and we will notice that my error that previously appeared here has gone away. Let me comment out that string business and also this. Okay, so again, you could go to Microsoft's documentation page here if you like, but it's straightforward once you've done it many times to overload the stream insertion operator. You can make it formatted more in a more pretty way if you'd like. You could let me be a little bit more detailed here. So cost colon the vehicle object dot cost. Again, since we are a friend function, we have access to this private member variable. Make a tab or set with if you like to make things look nicer, and mile range. And v object dot mile range. So it's there are certainly complexities that are underneath here with this returning by reference and passing by reference and having to specify 2 arguments in the function. So far, we've only been specifying 1 argument. Certainly complexities in this, but it is as simple as that. Now, when I say cout camper van, I will be displaying 20,000 and 400 in whichever order it is. Okay, and for some, I become overly reliant on red squiggles here. So we specified that we are returning an output stream object by reference. So this OS is not operating system. It's an output stream. It's a reference to an output stream object. So we do need to return OS here. Okay, so now, yeah, it is as simple as this, overloading the stream insertion operator. I'm hemming and hawing a little bit just because there are details in here that are interesting to poke into. So maybe we remove this reference and we see what happens now. Okay, so let's see, and we remove it in both places so that we're matching in our declaration. Okay, now we see an interesting thing here. Cannot be referenced. It is a deleted function. So I haven't gone into detail on this, but we might be able to. Look at the uh, I mean, we could just say this is the way you do it, and we're not going to investigate any further into it. Uh, So somewhere in the class definition of the output stream, this operator it's set to delete so that it can't be accidentally called. Um, and that's detail that I think I haven't gotten into at all in these videos, this semester at least, in fall of 2023. Okay, differs in levels of indirection, so that's an interesting thing. Um, what happens if we do not pass by reference? Hmm, are we still working? Is there a problem with this? Okay, attempting to reference a deleted function. So basic O stream. Okay, let me look into basic O stream real quick, or hopefully real quick. So there's basic O stream. There's one instance of basic O stream. It inherits from basic iOS. And we have this operator. So this operator overload. Okay. And at some point in this O string class, we should see an instance of delete. So there's an instance of delete. These are all grayed out. This if def, this is what's called an inactive preprocessor block. So what we're looking for is not in there because that's inactive. The inactive business sometimes has to do with the version of C++ that you're running. If you go to project settings, and you go to C++ language, you can update to use the various versions of C++, and some of these inactive preprocessor, these things called inactive blocks in the code will become active and they won't be grayed out anymore. See what I mean by grayed out? This is not grayed out and this is grayed out. Okay. Okay. Well, it's complicated. So let's not let me cease and desist for the moment at least. It just kind of bothers me. So pass by reference. I mean, maybe one more thing. What happens if we don't pass that in, then OS is undefined all of a sudden. So, okay. And are we still a friend and pass by reference? Okay. And we run again and we're good. Okay. Eventually I'll dig into that in more detail. So what about unary operators? What is a unary operator? A unary operator is an operator that takes one operand. So can we overload the not operator? And what should the not operator return? And should it take an argument here? So this is an instance of the not operator that is very common. So I haven't defined this file stream object, but this is one way to read the entire contents of a file. If you declare an input file stream object and you read until you read while you are not at the end of the file, the EOF function. So the not operator takes a single operand. So we actually, the reason we needed to pass in arguments here was because the operators were binary. Okay. So in the case of the negation operator, if we want to overload it, we're going to return another vehicle object. We could return another vehicle object. We don't need to take a vehicle object on the right side of the equation. There is no equation here. It's just an expression. Okay. So return not this dot cost. And yeah, this is so this doesn't make any sense in this case. I'm just going off the cuff. Negating and into a double doesn't make any sense. But if the vehicle class had Boolean variables like bool is a hybrid vehicle, we could negate that. So the negation operator is definitely for these. If you define a vehicle class containing only numerical values, the negation operator definitely doesn't make any, almost certainly doesn't make any sense, at least not anything that I can imagine. So let's not do anything like that. But one operator that might be desirable to overload is the plus plus operator. So the increment operator, increment by one. So again, whenever we say a plus, let's say c plus plus, because that's fun, and c is some integer like 0. So it's a unary operand. It takes one it's a unary operator. It takes one operand, c in this case, an integer. So we don't need to pass in an argument here. Our return type will be another vehicle object. Seems a little bit wasteful, but vehicle, maybe this is one approach we could take. We once again say resulting vehicle. And maybe we don't return a vehicle object, we return void. Yeah. And we say this arrow cost plus plus. So the plus plus operator in this case acts on a double. So that's kind of an interesting thing, incrementing a double by one. But this arrow mile range plus plus. And there are some complexities to overloading the increment by one operator. So let's just see if it works. So let's attempt, so we're gonna increment and then call the print operator. So let's increment motorcycle by one. Kind of an interesting thing to do. So we see no operand matches these types. Okay, so that's a bit surprising because it appears to be here. All right, but there's an interesting thing that's going on here. Post increment versus pre-increment. So this is the pre-increment operator. The post-increment operator, I haven't talked about this in a great amount of detail, but usually I use the post-increment operator. And I think maybe most people do. So evidently this thing is defined, this operation is defined, and we've also overloaded the stream insertion operator, so I can just print motorcycle directly. So will I see 3001 and 200 when I run this program? Yes. Okay. So that is overloading the pre-increment operator. And there, if you're curious about overloading the post-increment operator, making it to where you could say motorcycle plus plus, there's some complexities to that. You could just look it up. You can look up most everything. Um, yeah, so this is the postfix operator, and you pass in an argument here, and I just didn't care to get into this. And you can see in this case they're returning a type by reference. I just return void. I think this works without any problem. I'm curious of the approach that I took last year. Yeah, so I'm dereferencing the pointer to the current object here and returning a vehicle type. I mentioned that void is a possible alternative, so I'm not sure if there are particular benefits of seems wasteful to return a vehicle object instead of just returning void since you can modify it directly. I suppose each approach has its pros and cons. Okay, so I think yeah, I get into a few more operator overloading examples, overloading the arrow operator. So yeah, you can do this if you would like to. Um, doesn't seem like necessarily an extremely valuable thing to do. At least my the code that I wrote last year is not seeming particularly interesting to me. Overloading the new operator is kind of an interesting thing to do. New is an operator, and it's not a single symbol, as many of our operators have been plus symbol, less than symbol. Um, okay. This malloc business is an interesting thing. As I mentioned, that's a function from C. It means memory allocation or allocate memory. I think in this case you do have to use size t, and you can't say integers. You can't say integer in that case. Maybe. Okay. This can be quite the useful thing if you are wanting to dig a bit and see how much memory you're allocating and control how much memory you're allocating. So in my example here, uh, so you can see the code, and if you're curious to look into it, you're welcome to. I enjoyed going through this process whenever I wrote this code. I'm not quite sure why I was referring to vector there. But this is potentially an interesting application of overloading the new operator. And it also involves the use of the static modifier. Part of the reason I'm pausing so much is I'm just considering deleting these slides. Okay, but let's so that's a fair number of examples of operator overloading, not anything a person has to do, but it's a tool in C++, as I've mentioned. So I'll end this video here and then we'll talk about templates and also about vectors because vectors use templates, dynamic arrays.